Hey everybody, this is Mr. Munson. We are in Unit 5. We're going to deal with triangle relationships. As you can see from your student learning map, there's only 4 concepts that we're going to be dealing with in this unit. So it's going to be a very quick unit. It's going to be worth just as much as everybody else's unit. Unit 1, 2, 3, and 4, and so on. It's going to go really fast, so you guys stay with us. We're only going to spend a couple days on this. Let's go ahead and get started. Here comes your vocabulary words. So you should have been given a vocabulary sheet. Keep in mind, again, you're supposed to be writing your words on the rear part of this page. It'll say word phrase on the back. You write it there, and then you're cutting along an imaginary line so that you have these tabs that go over, that fold back over these words to kind of hide them. So you have a study guide, okay? So I'm going to be writing my words in this spot, in these lines. You're not to write them there. The other thing is you'll see on this first page, it says example, and there's not going to be a picture there, but there should be. If you look at the end of your vocabulary sheet, you'll see that there's a series of 5 pictures, and you're going to have to read through the description and figure out which picture belongs where. Okay, that's going to be part of doing your vocabulary this time around, part of your homework. Let's go ahead and get started. Now, just a real quick note, you could always take the word that's here and Google it and see what it's about. See if you can find similar pictures to what I have, and then that will help you as well. But I encourage you just simply read through the description and put it in place. Now, this first page is going to talk about some special segments we're going to be dealing with in triangles. This first segment, called a median of a triangle is basically a segment that has its endpoints going from the vertex, that's one of the corners of the triangle, to a midpoint, a point on another opposite side. Okay, let's go on. You might want to, at this point, just jump to the back pictures and see which one you think is best described by that description and draw it in that place. An angle bisector is a ray that divides an angle into 2 congruent angles. Now we're dealing with triangles in this section, so the picture at the end is going to be a triangle with an angle bisector. Next up is altitude. An altitude of a triangle is a perpendicular segment from a vertex, that's from a corner. So perpendicular means it's going to be a segment that's going to be perpendicular. It's going to create a right angle with another side, okay? So an altitude of a triangle is a perpendicular segment from a vertex to a line containing the side opposite that vertex. In the example below, and you're going to have to figure out which drawing, the altitude is inside the triangle to the left, however it's on the outside of the triangle to the right. Next up is a perpendicular bisector. The perpendicular bisector of a side of a triangle is a line, segment, or ray that is perpendicular, forms a right angle, right, to the segment at its midpoint. 2 properties, it's perpendicular and it bisects. Okay, so it's a bisector. Draw your picture in there. All right, a mid-segment of a triangle is a triangle, or is a segment that joins the midpoints of 2 sides of a triangle. So midpoint, obviously every side has a midpoint. So hey, listen, these 5 special segments, we're going to have some properties we're going to be dealing with. You have to know these words, so I'd start learning these. The other thing is that as the drawings in the back have only 1 of these special segments per triangle, each triangle contains 3 of each one of these. So for instance, a triangle has, here's a mid-segment, right? But it has 3 mid-segments because here's another midpoint, and there's another mid-segment, and then in the case I'll draw the other one. So there's 3 mid-segments. Those are the special segments for that. Each one of the special segments above, again, has, there's 3 of those special segments per triangle. Okay. So the triangle inequality theorem basically says that if I grab any 2 sides of a triangle, when I add those 2 sides together, they have to be longer than the 3rd side. Okay, so just in a general way, I'm saying A and B added together have to be greater than C. Okay, just a real quick reminder, the Pythagorean theorem: if a triangle is a right triangle, then the sum of the legs squared is equal to the hypotenuse squared. Okay, go ahead and write in the Pythagorean theorem in this spot right there. Now this is the Pythagorean theorem converse. Converse means you take an if-then statement and you kind of reverse the order. So in the Pythagorean theorem it says, hey, if the triangle is a right triangle, and then it says something about its sides. in this converse, it says, hey, if you have certain sides that do something special, then it's a right triangle, okay? So basically it says that, suppose I didn't know that this was a right angle, right? Suppose I didn't know that was a right angle. If I took the three sides of a triangle and plugged them into the Pythagorean theorem and was wondering, is this a right triangle? I could plug them in there, and if the left side equals the right side, then in fact it is a right triangle. But if I plug those two sides in and it doesn't equal c squared or whatever that other side, the third side is, then it's some other kind of triangle. Your only two choices being obtuse or acute. Let's kind of explore this down below. I call this the three bears theorem, and you'll see why in just a moment. Basically, if I take the two shorter sides that are given to me in some problem, here's three sides of a triangle, tell me what kind of triangle it is. If I take the two shorter sides and I square them and then add them together, and I take the third side, which is the longest side, and square it, if I was to compare that and find that a squared plus b squared is less than c squared, in other words, c squared is too big to be equal to it, right? It didn't actually equal it. It actually ended up being bigger than the a squared plus b squared. Then we find out this is an obtuse triangle, okay? And likewise with the acute, it basically is this. If I take the two shorter sides and I square them and add them together, and I find out that those two, when they're added together, is greater than the third largest side squared, then it's actually the c squared. The c is too small, right? It's too small to be equal to c squared. Then for it has to be an acute triangle. And then finally, if I take a squared plus b squared and it equals c squared, then it's just right, right? Okay, hopefully you see the analogy there. So you don't need to write this down. I just want to plant a seed for where we're going with our concepts, okay? So obviously you can see that, there's three angles inside this triangle. One's a 30, 70, and 80. That one angle is the smallest angle, that 30. And so what we find is that across from that 30 is the side AB. And that AB is going to be the smallest side. And across from the 80 is the largest side. I don't know what the numbers are, but I just know it has to be. And across from the 70 is kind of the medium side. So we'll call that one CB, of course. Okay? So if I had to order these from the smallest side to the largest side, that's how I would do it. Pretty simple stuff. So if you look at your student learning map, that's one of the concepts that you're going to be doing in concept number 1. And so likewise, they're going to ask you to, given some triangle like this, 3, 4, and 5, let's say, A, B, and C, and they say, hey, order the angles from the largest to the smallest, then you go find the largest side. The largest side is 5, and you point to the angle. So angle B is the largest angle. Across from the next side, which would be 4, is the next angle. That would be angle A. And then finally, across from the smallest side is the smallest angle, which is angle C. Okay? So you actually have the whole entire concept 1 done here in 1 minute. So then in concept number 2, if you're looking at your student learning map, we're going to look at those special segments, the median, the perpendicular bisector, and so on. And then the triangle inequality theorem says this basic fact. If I wanted to know what kind of numbers I could put in for the segment CB, we find that the segment CB can be either too long or too short to actually build a triangle given 3 and 10. Okay, and we'll discuss that a little further. But the concept is real easy. The way to set this up is simply take the side that we're looking for. In this case, it's X, or I could put CB, and you draw 2 inequality signs like that, both of them pointing to the left. And then you draw a line, And over here is the difference between the two and the sum between the two that are given, okay? So in this case it would be 10 minus 3, which is 7, and 10 plus 3, which is 13, okay? So this is called the range that that side can follow. X can be any number between 7 and 13. It can't include 7 or 13, but it's between those, okay? In the last concept, we're going to be trying to designate what kind of triangles are, classify triangles by their angles, given their sides. So we definitely know that the angles are different in this triangle because the sides are different, but we don't know if it's a right triangle, an obtuse triangle, or an acute triangle. It's drawn as a 3, 4, 6 triangle, but I don't know if it's drawn to scale. So what we'll do is we'll take the two smallest sides and we'll square them and add them together. And then we'll ask ourselves, with a question mark over that, is that equal to the largest side squared? And if it is, then it's definitely a right triangle. If it's not, then it's either obtuse or acute. So we'll have 9 plus 16, put your question mark here because we don't know, 36, and that ends up being 25, which is not equal to 36, right? Matter of fact, 36 is the bigger number, so we'll take the inequality and make it wider on the 36. So we find out that this side over here is too big to be equal to the 25, right? So it's not a right triangle, otherwise it'd be equal. It's really an obtuse triangle. So that's pretty much, in a nutshell, the vast majority of Unit 5, okay? So I hope that you watch that, and we'll go through some concepts and go through this chapter real quickly, and we'll be done. Real quick, and we'll be done. Hope you enjoyed it.